This is lesson 3-1 for Secondary 2 Honors Math, and we're going to start learning about circles in this unit. So to start us off, the first thing is that all circles are similar, and if you just stop and think about what we just said, obviously one circle is going to be similar to another circle because the only measurement we're recording is radius, and so that's going to have a ratio from one to the other. It says, for an example, if a circle has a radius of 8 and circle B has a radius of 4, what is the scale factor that maps circle A to circle B? So if circle A turns into circle B, it's going to have a scale factor of 1/2 because that's how 8 turns into 4. It's not going to be 2 to 1 because even though circle A is twice as big as circle B, it says it's going to map circle A onto circle B. And so that's how you would do that. Okay, number 2, we're going to show that the circles are similar by describing the transformations. So remember that with the transformations, all of them maintain congruence except for dilations, which maintains a similarity. And so we can see that obviously if we're going to map circle R onto circle T, it's going to get smaller. And so if we look, circle T has a radius of 1, while circle R has a radius of 3. So circle R is going to have a scale factor of 1/3 to turn into circle T. Now if it was the other way around, if circle T was mapping to circle R, then it would be a scale factor of 3. Now along with having a scale factor of 1/3, that's going to give us this, then we're going to translate it. So we're going to say it's going to translate according to our rule, X, and then we're going to go right 5 and then up 3. And so this is what we're going to say. So we're going to have a scale factor of 1/3 with a center at 0, 0. So when you're doing a dilation, you need to say both of those things, and then we're going to have a translation like that. Now that's not the only set of transformations you could have for this. There are other things that you could do. So you're welcome to do some exploration and see if you can figure out some other ways to do that. This is probably the easiest one though. Okay, as we talk about circles, we're going to be talking a lot about the angles that are created if we have lines that go through the circles. And so there's 3 different types of angles that we're going to study. The first one is a central angle. And the central angle is basically your vertex of your angle is going to be the center of your circle, and that's how you know you're dealing with a central angle. So angle DAE is a central angle, and CAB is a central angle. Now, when we talk about the angles, okay, we know that we can measure angles in degrees, but this right here, this is called an arc, which is a part of a circle, and we can also measure that in degrees too. So that's 60 degrees, and we are told right here that the measure of our central angle is equal to the measure of the arc. So this notation right here where it says the measure of angle BAC, that's talking about the central angle, is equal to the measure of arc BC, that's talking about that arc right there. And so that would mean that this central angle is 60 degrees. So if I know that, then I could say if this arc is 90 degrees, then I would know that this angle right there is 90 degrees as well. So you need to know that a central angle is equal to the intercepted arc. The word intercepted, it's like when the angle sides come out and they cross over the circle, that's the intercepted arc. Okay, the next type of angle is interior angle. And if you notice these angles, the vertex is not at the center of the circle, but it is in the inside of the circle. That's why it's called an interior angle. Interior angles are formed by these lines that come through our circle like this. And we'll talk about different names for that we can, or different types of segments we can have for that. But one that you're familiar with probably is chords. And so a chord is any line segment that begins on one point on a circle and ends on another point of a circle. So other chords that you're familiar with are like a diameter. And then we've got some chords here. It's just as long as both endpoints are on the circle, it's a chord. So we have these 2 intersecting chords. And so when we have these 2 intersecting chords, they form this interior angle. And then there's some characteristics about that angle. So the intersection of chords that forms this interior angle is equal to half the sum of the intercepted arcs. So let's look at what we're talking about. This chord and this chord intersect. They are intercepting or cutting off these 2 chords right here. Let me do that in a different color. These are our intercepted arcs. So I can call that one the A and B, just so we can know what we're talking about. Now another thing that I'm told in this picture is I'm told that this angle right here is 60 degrees. That does not mean that that's 60 degrees. Do you know why not? It's because this is not a central angle, and so that does not tell us the measure of our arc. This one, 56 degrees, is the arc, but that does not mean that that's what that angle is right there, so I don't know that one either. However, I do know that in a circle, I'm going to have 360 degrees total. I do know that this is a straight line, so if this is 60 degrees, this is going to have to be 120. I do know that this is a vertical angle, so that one's going to be 60 degrees, so this would be 120. So what I have, let me just draw it a little bit bigger here. I have these two chords that are intersecting, so this is 60 and this is 60, this is 120 and this is 120. And so what I do know is I do know that, well, look at this formula, the measure of angle DIC, so let's go DIC, so starting at D, going to I, and then to C, so this is the angle we're talking about. If I want to find out how many degrees that angle is, it's equal to half the sum of the two arcs. So 56 is one of them. The other one, I don't know. So I'm going to just put X right there. And so now I have a formula or an equation that I can solve. So if I multiply both sides by 2, so I'm going to get rid of that. So I'm going to have 120 is equal to 56 plus X. And then I'll just subtract 56 from both sides. And so that's going to be 64. And so what that means is that this arc right here is 64 degrees. So when you name arcs or when you measure arcs, those are in degrees as well, the measurement of them. It's like if you have an angle that's 60 degrees, that doesn't tell you anything about how long the sides are, it just tells you the measurement of the angle itself. So I have these arcs, 64 degrees, this one's 56 degrees. And I can't figure out the other ones. I mean, I know that all four of them will add up to 360, but I don't have enough information right now to find the rest of that. But this is something that you need to know right there, so I'm going to star that. Also on your vocabulary, you want to make sure that you've got these defined there. You're going to want to throw in these formulas. Your vocabulary is meant to help you, so put those in there to help you out. The last kind of angle we're going to talk about is what's called an inscribed angle. So the word scribe means to write it, and so an inscribed is inside a circle, so an angle inside a circle. So if you look at the picture, we see this angle right here. This is my inscribed angle, and you notice that the vertex of it is on the circle, and so this angle is all inside the circle like that. So that's my inscribed angle. Now it does have a special characteristic, and that is that it's half of the inscribed arc. So the measure of angle CBD, which is this angle, is equal to half of the arc that it intercepts, which is that arc. So the measure of angle CBD, which I know is 45 plus 28, is equal to 1/2 of whatever arc that is. And so I could solve that and find out how big that arc is. So 45 and 28 is 73. And so I would multiply both sides by 2. And so 146 is equal to X. So that means that in degrees, this from C, this arc over to E, that is going to be 146 degrees. So we're going to come back to these formulas and characteristics, and we're going to revisit them. But first, we're going to go to some vocabulary. So as we're doing this, you've got a lot of information that can go in your vocabulary. So there's a lot of new words, or maybe some that aren't new but are familiar to you. But we have a lot of words that go along with a circle. And so in this picture I have here, I have, of course, this circle right here. And then I have a whole bunch of lines or line segments coming through it, okay, creating angles and things like that. So we're going to talk about these different pieces and what they're called and what things we know about it. So number one, what is the name of the circle? So if I was going to say circle whatever, this would be circle Z. The circle is named based on its center. And so the way that you would actually write it is you would say circle, and it's got a little dot inside for the center, and Z. That is the symbol for circle Z. Okay, now number 2, it says, what is the name and radius of the circle shown in the figure? So where is a radius first off? So I look for a radius. It's starting at the center, and it's going to a point on the circle. So there's one radius. So we're going to say ZD is one of them, and it's going to be segment ZD. And there's another segment, ZE. Can you find 2 more? There are 2 more segments. So ZB and ZG. Now, of course, with segments, you can also call them, instead of saying ZB, I could say BZ. It's exactly the same thing. It doesn't matter if you're naming a segment, which 2, unless you're talking about, like, corresponding parts of triangles or something like that. But that's the name of the radius that is in the circle. Okay, number 3, what is the name of each secant line? Okay, that's a new one probably. A secant line, kind of a funny word, but what it is it's a line, okay, so arrows on both ends, that kind of thing, that goes through the circle. So something like this line right there would be a secant line. Can you find another secant line that is on the circle? So another secant line, let me erase some of these. So I've got this secant line. So another secant line could be this one right there, because it goes through the circle. It goes through at F and at G. The line segment CE, that would be a segment. If I extended it, it would be a secant line. The diameter, if I extended it, that would be a secant line. So the key is that I'm extending that. You don't need to name any that are not already lines. So we're going to have this line right here. We can call that either HB, and the symbol over the top is a line, or we could call it BE, or EB, or EH. So there's a lot of different ways we can just call that one line. So I'm just going to put a couple of them. And then the other one we're going to name is this one. So you could call that one either HF, HG, FG, GF, GH. So I'll just put one of those here. So those are secant lines. What is the name of each chord of the circle shown in the figure? So we only have to name the chords that are shown, which means a chord is going to be a segment. So like from C to E, that would be a chord. So CE, and it's a segment, so we're going to put a little segment over the top of it. Okay, can you find another one? Obviously the diameter is a chord, so BD. We've got some other chords. We could say that BE, because we have a point B and a point E, that segment BE is a chord. And you might say, well, that's part of a secant. That's true. A secant does contain a chord, and so they're kind of like parts of each other. FG would also be a chord. Now notice that I'm naming that as a segment, which has a beginning and ending, as opposed to up here, if I said FG as a secant line, I would have arrows at the top. Okay, number 5, what is the name of each diameter of the circle that is shown in the figure? So a diameter starts at one side of the circle, goes to the other, and it has to go through the center. And in this picture, there's only one that is shown. When you name a diameter, you do it from end point to end point. You're not going to name it with a center point. So it would be BD or DB. Those are the only 2 names that would be right. Okay, number 6, what is the name of each tangent line? So a tangent line, there's a couple kinds of tangents that we talk about in math. In this context with circles, we're talking about a line that is tangent to a circle, and by definition what happens is a line that is tangent touches or intersects the circle at exactly one point. So this line right here that I've done in green, that's a tangent line, and it is intersecting the circle right there at point G. So the name of the tangent line would be GA, and again it's a line, or AG. Now you can have chords that are tangent or segments that are tangent. And so as long as it's tangent, that's going to be anything that will touch at exactly one point. So like right there, that would be a tangent segment. So we'll talk a lot about those. When we get into trigonometry, there's another type of tangent that we talk about. It is related to circles, but we talk about it a little bit differently. Okay, number 7, it says list each vocabulary term that ZG is an example of. So if we look at ZG right here, what is that an example of? Okay, a radius, that's one. Would it be an example of a chord? The answer to that is no, because Z is not on the circle. So it is a radius. Is it a tangent? Is it a secant? Is it a diameter? What else is it? There's actually nothing else that ZG will be. So just radius is it. Number 8, list each vocabulary term that dB is an example of. So let's look at dB. So dB, that is an example of a diameter. It's also an example of a chord. Now, I'm not going to say that it's an example of a secant line because the way that it's pictured in the picture, it has endpoints, so it's not a line. So I'm not going to say that, although if it extended like that, then it would also be an example of a secant line. Okay, number 9, list each vocabulary term that point G is an example of. So this point right there, that's a point on the circle. It's one of the endpoints of a radius. It is one of the points on several different lines or line segments. However, the main thing that we want to see here, because this is the point where the tangent line touches the circle, it is called a point of tangency. So that's a point of tangency. There are no other points of tangency that are pictured in this drawing right here. If we put some other line segments in there, then yeah, we would have some more points of tangency, like D in that one that I just drew. But we're just going to do the one that's already there. Okay, and then the last one in this section, it says list each vocabulary term that BH is an example of. So BH, it's just talking, it says, if you look really carefully, it's got little arrows at the end of that. And so that is the line BH. So we're talking about this whole line. And so that's going to be a secant. Now if I said line BE, I would still be talking about the secant, but I'd also be able to say it was a chord. I would also be able to say, well, I guess that's it. It would be a chord. But since it said BH, I'm not talking about the chord. I'm just talking about this entire line as a whole line. So just a secant line. And that's it. Okay, the rest of this lesson will be continued in the next video.